assume it'll work. There's 17 people waiting here, so in the future you should all feel free to go on the YouTube thing instead. But okay, I assume that's still working. All right, so I'm Mohit. This is Advanced NLP, CS685. And yeah, today we're just going to do some like logistics stuff. I'm going to talk about the grading, the final project. This is a very project-focused class. And then we're going to do some demos at the end. So there's not going to be much like actual content today. Next week, because of Labor Day, I think we only have class on Wednesday, so we'll start our first real class then. So like I said at the beginning, these lectures, at least for now, I will try to live stream them on YouTube. I have no idea if this is going to work or not, so we'll see. I mean, I'm on the Wi-Fi right now, so it might not be great, but that's a plan right now. If that fails, I could just record them and post them afterwards. And yeah, for people who want to watch remotely, so I'm just not talking to you, talking to the 17 people here, feel free to ask any questions in the chat box, and I will like periodically try to switch over to that and see if there are any questions. I may forget though, so okay. When we actually talk about real things, there will be a weekly quiz. It's not going to be graded for correctness. It's mostly to see if you can write stuff in response to prompts, and it's basically like attendance. So all of our assignments will be submitted through Gradescope. I think I added everyone who was registered yesterday. Is that true? Did everyone get added? Okay, if you did not get added to Gradescope or Piazza, those are the two most important things. So send an email to the class Gmail account and we'll get you sorted out. And we'll be using Gradescope for all assignment submissions and feedback for your project stuff and so on. All right, so are the TAs here? I told them to be here, but I guess they did not come. That's sad. Okay, so anyway, the TAs are usually more responsible than this. So they're my PhD students, so they better be. Tu and Catherine, they'll be holding office hours, not this week, starting next, like Thursday or something, we'll start holding office hours. And yeah, you should feel free to ask them about anything related to not only homeworks, because you won't have too many homeworks, but mainly about your project stuff. Feel free to ask the TAs or me, but they're also there for help, and depending on your project, they may actually be better sources of help than I am. Regarding email, don't email my personal email or any of the TA's personal emails. We probably won't respond. Use this if you want to get in touch with anyone, unless, of course, you have something private, in which case, email me. The course website, hopefully you all have seen this. I posted it on Piazza. Everything like the lecture videos, the slides, the notes, etc., will all be on here. Yeah, we have a new NLP at UMass lab page. So if you're interested just generally in checking out research on NLP that's going on at UMass, you can check that out. All right, are you all here for 685? Okay, yeah, just sit wherever. This is a confusing building. Oh, Catherine, that's true. Okay, so maybe you can, I already went over your intro.
Yeah, literally, they were just like, how did we get there? I'm like, I don't know, but I'm a TA.
Yeah, I mean, okay, now you know, but you may not ever have to come back here.
I don't.
So this is Catherine, one of the two TAs.
Yeah, so my office hours will be from 11 a.m. to 12 noon in CS685. I'm 21, but you can do it about me. I've never been in there, so I don't know what the stuff is.
Catherine is, this is her first year on campus,
Yeah,
so she's probably like many of you in that.
I'm studying a PhD student, so I don't know where anything is.
You can stay or leave, up to you. All right. So all the office hours will be both in person as well as what we're trying to do right now. It may or may not work. Is we'll also open Zoom during the in-person office hours. So if you want to, if you don't want to come to this cube, then you can just join the Zoom, and we'll be monitoring that as well. I don't know how that'll go if it's like a particularly busy week, but we'll see. All right, so yeah, my office hours are Thursdays, 3 to 4 p.m., not this week, starting next week, and Tues are on Friday. So we put all the Zoom links if you want to join by Zoom on Piazza, not on the actual site. We have found in previous years that during the exam week or some like particularly rough homeworks, I don't think there should be any this time, but maybe there will be, that there's a lot of people who want to come to office hours, so we may extend them during those weeks. You should just demand that on Piazza if you want it, but otherwise these are 1 hour office hours. Okay, so yeah, I mean, obviously this room is like not the biggest, and if everyone were to attend, you'd all just be packed right next to each other. So we're not going to increase the capacity of this class. If you're on the wait list, I guess you should hope some people drop so you can get in, but usually in past years I have tended to increase the capacity after the semester starts, but that's not going to happen this time. Don't email me or any of the TAs with like, pleading to get in the class. We can't help you. You could email Jess, but she also probably can't help you at this point. And yeah, here's some ad drop deadline stuff. All right, so there are many ways in which you can submit feedback to us or me, depending on what you want. There's Piazza. You can make anonymous posts on Piazza. I'm not actually sure what the settings are on there right now, but it should be, I don't know if you can make anonymous posts that are anonymous to us. If you want that, you can ask, but like you can also use this form, which is totally anonymous. So generally we find that people post more interesting stuff on this form. So feel free. I will monitor this form before every lecture and go over some of the responses. For today, I was surprised to see there were actually 5 responses already. So let me quickly answer some of these questions. So someone asked, does this course require prior knowledge of NLP? No, it does not. However, it does build a lot on machine learning and probability. You need to have a good programming background. So if this is something that you're weak in any of these areas, you will need to study on your own to brush up because some of the assignments and also for the final project especially, you will need to do a lot of implementation of fairly complicated models. That said, we'll go over a lot of this background in the class as well. So it's really up to you if you want to study extra or not. There's a question on final project groups. So this year, just like years in the past, we will be enforcing a group size of 4. So you're going to have to find a group of 3 other people, settle on a project, and do that project. I know this is not ideal. A lot of people like to do projects that are like by themselves or with one other person. There are lots of issues with having a group of 4 people, right? Usually someone doesn't do anything, and then someone does everything, and then the other 2 are just like there. So we know there are problems, but also like it's not manageable for us to give you feedback if there are a ton of groups. So this is the best balance we found in the past, and now that we only have 2 TAs, it's going to be even more difficult to give you prompt feedback if we do smaller groups. So 4 it is. Some of you, if you're a PhD student working on a somewhat NLP related or machine learning or something that you can kind of tie into NLP related research project with your advisor, I usually give exceptions for that, so you can use your own research as part of this project. I mean, it can't just be like, in computer systems or something. It has to be somewhat adjacent. Others of you who might be doing research with me or another NLP faculty here, might also get exemptions, but in general, most of you will be in groups of 4. Okay, and will we have notes? So I'll post the slides before every lecture. Sometimes I forget, but I'm usually good about that. And sometimes I will take notes during the class, like maybe working through some derivation or something. I will post those notes after the class. All right, any logistics-y questions so far? Should also add that I'm really bad at learning names, and with the masks, there's no chance. So don't expect me to know your name. Okay, so prereqs, like I was saying before, Python, everything in this class will be on Python. All your assignments will be on Google Colab, actually. So if you haven't checked that out, you can play around with it. It's basically an interactive notebook that gives you a free GPU, although it seems like Google is getting stingier and stingier year by year. So the GPUs this year may be a little rough, but we'll see. And the deep learning framework that we'll be using is going to be PyTorch. So it's not necessary to know that right now, but you will become familiar with this through all the homeworks that we give you. Yeah, so there's some math stuff. Matrix calculus is good to understand backpropagation. Excitement about language, yes, it's like the main thing, and so on. So, all right, grading breakdown. This is basically the same as last year. So these like weekly quiz things that I was telling you about will make up 10% of your total grade. These are mainly like the equivalent of participation. You will have 2 to 3 problem sets, depending on how motivated we are to create problem sets, because it's actually quite difficult these days in NLP. You'll definitely have at least 2, probably 3. Last year, we didn't get to the 3rd one. And these will all include like some writing and some programming. Actually, I think the first one, yeah, that one also includes a little bit of programming. All homeworks will be on Google Colab, as I mentioned. So homework 0, the very first one, is already available. You can check it out. It's due it's on the slide, a later slide. Okay, you'll also have an exam. That'll be 25% of your grade. It will be in late October or early November. Even though this class is in person, I liked how it went last time, where we just made it open book and internet and gave everyone like a day to complete it. It's obviously harder to write problems that are not easily Googleable, but it's not your problem, that's mine. And this exam has been historically pretty difficult. So yeah. Because it's hard to write good problems about NLP that are easy. So in the build up to this exam, I will give you all the previous midterms and their solutions. There will be some new stuff that is not covered on these previous midterms, and you can come to office hours and brush up. But we can talk more about that exam later on. And finally, the most of the class, your grade, 35%, is on these final projects. So there are only going to be 2 deliverables for this project. The first one will be coming up later this month, the project proposal. So you're going to have to form your team, write like a 3-page thing about your project, and we will give you feedback on that. So that's worth 10% of your grade. And then you have a final report. I don't know if, because obviously last time it was remote, so we didn't have any sort of presentation. This time, I don't know, we'll see. But you definitely will have to write a report. And because there's like not that much other work in this class, we grade these pretty harshly. So we do expect a ton of work to go into this. There's not that many milestones, so you could feasibly write your proposal, do absolutely nothing until the end of the semester, and then write something for your final report. But you will do really badly. So you should budget your time accordingly, meet regularly with your team, and do a good job. All right. Regarding readings, there are no textbooks that you need to buy. All readings will be PDFs on the website. There are usually going to be NLP research papers and notes. Okay, so one thing I want to say is that the fall 2020 version, which I keep referring to, was completely remote. All of the videos and stuff you might have seen are on YouTube and all the materials. And I was really thinking, like, could I just make you click the YouTube links and watch those while I just stand here and play on my phone? But I decided not to because I probably didn't do a very good job on those videos. Also, you probably want to ask me questions. That was something that the previous year could not do or couldn't do effectively. The YouTube thing is on a delay, so it makes it very hard to have like a back and forth. And there will be new material this semester too. So that said, like a lot of the basics, especially the first couple lectures, will be, the material is basically the same. So if I do a bad job explaining in class, you can watch the 2020 version and maybe I did a better job then, who knows. But all of that stuff is available. All right, so any questions about anything at this point? Yes? Yeah, there's usually a curve at the end depending on how badly people did on the exam. Any other questions? Oh, I forgot to put a slide showing the grading breakdowns of previous years. I know everyone loves that, to see how many people got A's and B's and so on. Most people get A's, some people get B's, few people get below that. And it's very dependent on your project quality. All right, no more questions? Yes? Yes, I posted it, I think, right before I came to this room. So there's all of the project deliverables, the proposal, and the report. We'll give you Overleaf templates. So Overleaf is like a LaTeX web thing. We basically want you to use that template. So if you don't know LaTeX, you need to learn it to write these reports. But it's pretty easy to pick up. Yeah. So what I need to do is get permission from some of the previous year, like the good ones, and or maybe some bad ones also, and I'll show you both. Okay, great. So let's just quickly go over what natural language processing is. So a natural language, right? It's not a programming language. It's not like something man-made like Klingon. It's a language that evolved naturally through human use. That said, this definition is a little outdated now. I mean, people are using NLP models for programming languages. I'll show you a demo of that at the end. Well, I guess people are using techniques from natural language processing to solve problems on many other languages that are not actually natural languages. Okay, and what does processing actually mean? So there are a couple different things that are generally associated with tasks that people commonly perform in natural language processing. There's supervised learning. It's probably one that many of you are familiar with. You have some text and you want to map that text to some sort of output, like a label. So for example, in, say, sentiment analysis, I get a review and I want to know if it's positive or negative, right? In unsupervised learning, I have a bunch of text. I don't have any labels, and I kind of want to infer some important or interesting patterns from the data. So this is a more like exploratory setup, perhaps. So things like topic models, for example, could be described like this. There's a new class, okay, it's not new, but recently has garnered a lot of interest in generating text from some input. So for example, I could give you a prompt like, write a story about a fox trapped in a house or something. And then I could have a model actually write that story, right? So you can actually set up a lot of different natural language processing tasks as text generation tasks, and we'll see a lot more of that later on in this semester. So before we get to some tasks and examples, I always show this slide just to make sure that we're all aware of certain terms that will be used throughout the semester. So let's say I have this sentence, Alice talked to Bob. Right, at the base level here, I have these different characters, right? A-L-I-C-E, space, and so on. And you know, not a lot of modeling historically has been done at the character level, but nowadays, there's a lot. Nowadays, I mean like in the past 6 months, this field is very quickly moving. There's been a lot more interest on like character and even byte level models. So we're going to talk, that's going to be one of the new things this semester that we talk about. So then there's a level on top of these characters, right? There's, before we get to words, right, there's even these like suffixes and prefixes and, you know, things that carry meaning. So talk here, the stem of this verb, and ed, the suffix, which is indicating that it's in past tense. And we get to words, right? Alice talked to Bob. We're all familiar with those. And one thing that many NLP researchers are interested in is learning like syntactic patterns from these words. So syntax refers to the way in which these words are put together, or some kind of grammar. So part of speech tags are kind of the lowest level of syntax. So here, Alice is a noun. Talked is a verb in the past tense. To is a preposition. Period is a punctuation, and so on. Then we get constituents. So we can actually form a tree of the sentence, right? So for example, this phrase, to Bob, is a prepositional phrase. And talk to Bob forms a verb phrase. So you can see this hierarchical composition. And then combining this verb phrase with a noun phrase produces a complete sentence. So I forgot to check for questions in the chat. Let's see. The streaming works great, thank you. Can we use packages like NLTK for homeworks? We will specify that at some point when we get to the homeworks, but you shouldn't need it for the first homework. All right. Oh, this is an animation. Okay, so then after we get past this syntactic layer, we can also talk about semantics, so the actual meaning of the sentence or the phrases, right? So what does Alice talk to Bob actually mean? Well, Alice was the agent here. She was doing the talking. Bob was receiving this information. So we might have some sort of external structure in which we are mapping this sentence into, right? Some kind of meaning representation. Or we might just map this sentence into a vector of numbers and not have these explicit representations. So that direction is where the field has currently moved, but we'll talk about that in a bit. And then discourse information is when you have multiple sentences. You might have a whole document, right? And you want to know how does information kind of propagate and connect and refer to different things in the same document across multiple sentences. So you can get higher and higher and higher up this tree of linguistic structure. Okay, so let's get back to the processing part of natural language processing. So we talked about supervised learning, right? And supervised learning traditionally works in such a way that you're given a data set of labeled examples. So if I'm doing sentiment analysis, I commonly have a collection of reviews from, say, Yelp that I have manually downloaded or automatically crawled, and I know the scores associated with those reviews, right? Someone could write, I really hated this restaurant, and then give it a 1 star or something. And so I want to train a model that, given that review, this restaurant was horrible, predict that this is a 1-star review. And then the goal is I can use this classifier that I've trained on new reviews that come in. So this slide is a little outdated. I think nowadays people don't just use pure supervised learning, but they generally transfer from a very large self-supervised model, which we'll get to in a bit. But tasks that are commonly, they commonly require some sort of labeled data set, at least we can say that much, sentiment analysis, question answering. There's a lot of different question answering data sets out there to solve various forms of QA. Entailment, this task is generally set up at the sentence level. So given two sentences, does the first sentence entail or contradict the second? And machine translation, there's a lot of parallel data produced by translators, like here's a sentence in English, here's the same sentence in French, do the translation. Okay, so any questions about supervised learning? All right, probably have more when we actually talk about some models. This is just a very high-level overview. So self-supervised learning is very similar conceptually to supervised learning, except you don't need a labeled data set. Like, you don't need to spend effort creating a labeled data set. You don't need to go, say, to Yelp and crawl these reviews and their scores. In self-supervised learning, your data set just comes for free from like text itself. So as an example, let's say I'm given just a huge corpus of text. Let's say I crawled the entire internet. So there's like the common crawl, which kind of attempts to do this. I can set up a task. I can set up many self-supervised tasks on a data collection like this. The most basic task is language modeling. This will actually be the focus of basically the entire semester. So given some input text, let's say, John went to this is my input. A language model is trained to predict the next word. So I get the labels for this task for free, right? Because in my text collection, I might observe, John went to the store. And so I can set this up as a supervised learning problem where I give the model John went to and I ask it to predict store. So you can see how like any text can be turned into an instance of language modeling just by chopping off one word and asking a model to predict what word that is. So you can think about why this kind of task is very useful. We'll get into that a lot more when we start talking about language models and representation learning. The general idea is that if a model is going to have to predict store, given John went to it's going to have to learn a whole lot of information about the words and the syntax and the semantics of that input, right? You need to know that, if the verb went is used, then it's probably a place that John is going to, right? Also, John here is probably a person, right? So, there's so much information that this task is kind of forcing the model to learn. And if you do it at a huge scale, then the models can actually learn a lot of stuff. So we'll see that in the demos at the end of the class. Okay. And yeah, there's masked language modeling, which we'll talk about later. So I guess I already answered the yellow. I generally put these questions in yellow boxes and intend you to answer them, but I messed up here. So we can gather as much data for a self-supervised task as we have just raw text, right? So huge amounts of data can be used here. And you can compare that to the sentiment analysis case, right? Like for Yelp, there's only a fixed number of Yelp reviews. I mean, I'm sure there's millions potentially of reviews that people have written, but that's still not like infinite, right? Okay, and so there's representation learning, which is another thing that we'll be concerned about in this class. And here, I kind of alluded to this before, but we're given some input text, and we want to create a representation of that text, like a numerical representation. This is often in the form of these real-valued, low-dimensional vectors. So for example, I don't know, maybe I have the word today, and I want to represent it in some vector space. I represent it with this 4D vector of like random numbers. And the hope is that the word today might be close to the vector for yesterday. It might be close to the vector for Wednesday. It might be far away from cat. And so maybe there are some nice relationships in this vector space that correspond to the meaning or the syntactic usage of the word. Okay, and so over the past couple of years, the field has kind of shifted. So given a supervised learning task like sentiment analysis, Before 2 years ago, you would essentially take a model and you would train it from scratch on this data set of like Yelp reviews. So initially the model would be completely random. It would know nothing about language. And through this process, it would learn how to solve the task of Yelp reviews. But what we found now that there's self-supervised learning is that I can take a model, I can train it on this task of language modeling, or like predicting the next word given some input, and then I can transfer this model over to a task like sentiment analysis. So this means that the model no longer starts from like a random place, right? It already now knows something about, like John is a person, went means that he's going to some place, and so on. And so it doesn't need to learn all of that just from the Yelp reviews. It's now learned that from this huge data set of text. And so all the Yelp reviews are doing is telling it, okay, I may need to focus on this type of sentiment in the representation space to emphasize this, and so on. So this has really revolutionized the whole field, this concept of transfer learning. And now the dominant trends in NLP are to continuously reduce the number of labeled examples that we actually need. So you might have started with 100 million Yelp reviews. Obviously, it's not practical to get millions of Yelp reviews, millions of labeled examples for any task. It's much more practical to get, say, 10 labeled examples, right? I could manually create 10 labeled examples for whatever task, and then put that into one of these language models, and then have it solve the task. So that's kind of where the field is going. We'll talk a lot about some of these new approaches. All right, so rough list of topics. I hopefully have made the point that these language models are interesting and impactful and very important, so we're going to be spending a lot of time on those, specifically neural language models. So these are neural network models of language. In terms of model architectures, we will briefly cover recurrent neural networks. Then we'll switch over to transformers. This is something I think I did based on the exam scores last time, a pretty bad job of explaining. To be fair to me, it is like pretty complicated architecture. So I'll try and do a better job this time. And we will cover many variants of this transformer architecture, which kind of dominate the field right now. There are specific classes, how should I say this? Instantiations of these various models. So Elmo is a type of recurrent neural network. BERT is a type of transformer. GPT-3 is also a transformer. You have maybe heard of some of these like Muppet-like terms like Elmo or BERT, or you might have seen a lot of hype press stuff about GPT-3. And in this class, you will learn how all of these things work. We'll talk about a bunch of tasks. We'll also focus a bit on data collection. So one of the homework after this one will actually have you create your own data set. For some tasks, you'll create like a set of guidelines. You'll pair up with someone and then ask them to create a small labeled data set using your guidelines. And then you'll train like a BERT or something on your data and see how it does. But this is very important, right? Now that all these models can do all sorts of things, it's important to focus on the quality of the data. There's also a lot of ethical issues now surrounding the data and the models, right? So if you're learning some model from, say, the internet, obviously the internet is just like a total cesspool. So this is not it's going to have some undesirable outcomes if you try and apply it naively. So there's a lot of not only like bias type issues, but also privacy issues of important information leaking out of some of these models. We'll cover all of that. All right, and if you're interested specifically in the new topics that we'll cover that we haven't covered in previous semesters, this might not make sense right now, but you can come back and refer to this slide later when it does. Also, towards the end of the semester, I may run out of topics, so feel free to suggest other things using any of the anonymous form or Piazza or whatever. All right, so I want to give like half an hour for the demos at least. So yeah, this year I wanted to just go over the whole final project process right now at the very beginning of the semester, because you should really just start thinking about it immediately. Start thinking of some ideas, even if you don't know how to accomplish those ideas yet. Start reading research papers. So the first homework will force you to read at least one paper, but you should be reading many others to decide, what's an interesting project to potentially work on. So usually I give this this information a few lectures in, but I decided to do it today. So first, some logistics stuff. So, oh, is that a question? No? All right. That's a good reminder to check this chat box. Can we have the class timings? It's 4 to 5:30 on Monday and Wednesday. Okay. I don't know if that's what he meant. But oops. All right. So yeah, we're going to give you 2 weeks to form your groups, and again, groups of 4. So there will be a Google form. Once you have figured out your group, you should fill out the form, and we'll keep track of it. We generally use Piazza for groups who have 3 people and they're trying to find one more and so on. So we'll make that thread open after the class today. And if you're unable to find a group by September 15th, we will randomly assign you to one. So everyone will eventually be in a group. All right. As I said, only 2 deliverables, at least 3-page project proposal and 12+ page final report. And we basically give you full freedom. So as long as you're using some sort of text data and some sort of model is being implemented, we're fine with it. But yeah, again, it has to be a substantial amount of work. This is a semester-long project. So you could, build a new NLP model or system. You could apply an existing one for some task and do some analysis on it. You could create a new data set and evaluate a bunch of different models on it. There's so many different things you could do, right? So all of these are acceptable, but in your proposal, you will have to justify why you think this will take, the entire rest of the semester to complete, what the expected outputs of this thing are, and so on. So we'll try and give you feedback. In general, we try not to force a group to completely change their project idea. We might give you additional things to focus on and so on after the proposal. Okay, so when you're writing your proposal, there's something to think about. Is the main thing is, what is the research question? So what exactly is the task you're tackling? Why is it important? What have people done in the past? This will involve doing a literature review of all the papers that have been published in this area. How will you measure the success of your project? This is getting increasingly more challenging as the tasks that we're able to do are getting more and more underspecified, right? Like if I have a task, generate a story given some prompt. How exactly do I evaluate that, right? Who is going to tell me whether the story is good or whether it sucks? It's kind of subjective, right? So it's important to have at least some plan of evaluation. And yeah, we like ideas that are creative and ambitious. We're not going to grade you based on whether your idea works. In fact, the majority of ideas, projects here don't end up working because it's actually hard to, by work I mean like being the best possible system for that task, right? You should at least get your models to do something. Okay, so yeah, there's this thing, the Heilmeyer Catechism is a good way of thinking about these research ideas. It's also a good way of writing your proposal so that me and the TAs understand it. Try and first write out your idea using no jargon at all. Be as clear as you can for like a lay person could understand what exactly it is you're accomplishing. And yeah, we can skip the rest. I think I covered it. So you're going to have to do a lot of reading of NLP papers, not only for this project, but just in general throughout this class. If you want to do some reading for your final project, you should mainly look at conferences. ACL, EMNLP, and NACL are the three main conferences. There's a couple journals also in which new NLP research is published. Again, the models, the topics that we're going to be covering in this class are all very, very recent. So there's no one who's written like a book on many of the things that we're going to cover in the lecture. They've only been covered in very recent conference publications. So you might find that the writing quality is not that great, which I'll try and make it understandable throughout the class. All right, so I'm just going to skip this because I feel like I've said a lot of these things. So there's some examples from previous semesters, like you asked. These are just of the projects. I think you probably want to see the proposals as well and the final reports. But these are things that people have worked on in the past. So obviously things like sentiment detection or humor or sarcasm detection. There's kind of structured prediction tasks that involve things like parsing or relation or event or entity extraction. There's a bunch of text generation tasks. One year we actually made the whole class do a machine translation project, which did not go well because Google Colab didn't give us the best GPU, so it was hard for students to train their models. So we're not going to do that, obviously, this year. There's question answering, dialogue systems, so many different things. This is only a small subset of all the possible things that you could do. So you really have to read on your own when you're coming up with these proposal ideas and find some subfield that you're interested in. All right, as I said, all of the projects need to use some sort of text-based data set. And it might depend on your project, right? If a data set doesn't exist for your task, you might have to make it yourself. If it exists, you might want to spend more time building new models and so on. So there are many sources of labeled NLP data sets, these shared tasks. All of them are publicly, most of them are publicly available. A lot are under some sort of license, and we can get them for you if you request them. There's also general text resources, data sources. So Project Gutenberg is a great source of like public domain works of fiction and some nonfiction as well. Yelp has released some dumps of their reviews. The Common Crawl is a good source of web. You can crawl Twitter, so on. All right, so many tools and stuff. I will just not cover this. You can read this slide if you're interested. All right, so before we get to the demos, homework 0 goes out today. It is due September 13th at 11:59 p.m. on Gradescope. Oh, I forgot to mention our late policy. Kind of forget what it is. I think it's like 3 days. So you have 3 late days to use for these homeworks. We don't accept them for the final projects or the project proposal. So the group projects, you can't use any late days. For the individual homeworks, you'll have 3 total late days. And of course, if you are sick or you have some legitimate excuse, just email the instructor's account and the graders will note that down so we don't penalize you unfairly. All right, so yeah, the immediate things for this month are your homework 0 should be pretty straightforward. For those of you who are not as experienced with coding, it might be a bit of a Python refresher as well. And it will also introduce you to some PyTorch basic functionality. So plan to take some time to complete it if you are not familiar with those things. Yeah, again, we'll ask you for your project teams by September 15th, and we'll give you another like 10-ish days to do the project proposal. So those are all the things you will have to do for this month, in addition to doing the readings for the class. All right, any questions on anything that we've discussed so far? Yeah, everything will be on the course page. The one thing that you won't get if you're not enrolled in the class is the solutions to the homeworks. We will post those in the Piazza. So I guess if you're on the Piazza, I don't know if waitlist students are on the Piazza. Yeah, then you need to email us to get added to the Piazza and Gradescope account. Yeah, and if you get enrolled somehow after this deadline, we'll just take it via email or something. Other questions? Yes. Oh, that's a good question. So there are resources that you should not use for the final project. We have a research GPU cluster called Gypsum. Some of you may have access through like independent studies and other stuff. You're not to use that for any course project related things. And if we catch you, and we have in the past, we will terminate your account. So it's not me that's monitoring these things, it's the PhD students who are using Gypsum, and they're kind of ruthless. So be warned. So in terms of resources, there's Google Colab, which most groups have used in the past. I think you can probably get some free Google Cloud credits or some other cloud provider credits to use GPUs if you need. Yeah, we can talk if you really need some like huge scale resource. That is probably not a good project idea. So we will give you feedback like that based on your project proposal write-up. There are lots of scripts that students have written over the years to get around some of the limitations of Colab, which hopefully they still work. I will share them when that time comes. Yes? Yeah. If you magically have access to some huge GPU resources, feel free to use that. No one's going to stop you. Yes. Do all the students? Oh, that's a good question. So we actually, generally the default is yes, but if there is someone who's been doing nothing, we've had many cases where the other 3 or other 2 members will write us an email. So generally you have to notify us that this person has not been doing anything. We will follow up with that student and generally give the other students a higher grade and this one a lower grade. But we'll talk about that more when you actually start submitting your reports. But yeah, it's up to the groups to notify us if you want like different grades. That can be a bit awkward, but you know, it's not perfect when you have 4 people in a group. All right, let me check my YouTube chat. How can we form groups if we attend online? That's a good question. There will be a Piazza like searching for teammates thread where you can do that. In general, people will also post their time zones. So if you're not in Amherst, if you're in another country, maybe there will be people who will be willing to join your group in the same time zone. Can the project topic be related to feature extraction, signal processing stuff? If you're applying it to text data, then sure. If you're applying it to non-text data, then probably not. Okay. Great. So what is the next thing I was going to do? Oh yeah, I was going to do some demos. So yeah, usually I just give this demo. So Allen NLP is an open source NLP library. I hope my screen is still showing on the YouTube. I will check my the chat box in a few minutes and see. So yeah, the Allen NLP is part of the Allen Institute for AI. It's a sub-team that focuses on NLP, and they have this nice page of a bunch of demos of various NLP systems for different tasks. So we can start with one of the most basic tasks. Can you read this? Should I make it bigger? Is that better? Okay. So in this task, maybe it's easier just to show you. So I can pick a sentence like, oh, I can even write a sentence if I want, but let's just use this one. If you like Paul McCartney, you should listen to the first Wings album. So the task of named entity recognition is going to identify all of the people, places, objects in the sentence and give me boundaries on where does this name entity start and where does it end. So if I run this model, get if you like Paul McCartney, you should listen to the first Wings album. So you can see that Paul McCartney is recognized as a person. The Wings is recognized as an organization. So where do you think this kind of task would be useful? Why would I ever want to do something like this? Anyone have any ideas?
You're looking at legal documents and you want to figure out the cases and companies and
Sure, yeah, that's a good use case. Anyone else? What's that? Voice assistant. And why would it be useful in a voice assistant? Yeah, exactly. So if I say, like to my Alexa or something, book a restaurant or book a table at restaurant X for 6 p.m. or something, that is going to go into some sort of like slot-based system, like you mentioned, where there's going to be some sort of interface to an actual like booking function, right, which says book place X at time Y, and you need to fill those slots. So you need to extract the utterance of the name of the restaurant and put it into there. All right, so this is one task. Let's do a couple more. You can also obviously just go to this site and play around with these. So open information extraction. Here we're extracting these kinds of triples. So like argument 0, verb, argument 1, these kinds of relations between two entities. So here, Alex, Honnold, and New Jersey skyscraper are related by this verb climb. There are very similar things if you look at, for example, semantic role labeling. This is extracting some sort of predicate argument structure. If I click this, so in this task, I'm going to get, for every verb predicate in the sentence, I'm going to get a list of all the different arguments that are, and so there's different definitions of like what does arg0 and arg1 and stuff mean. But here, this is clearly the agent, and here's a modifier to this verb, honestly think, and then this, like what was he thinking, right? That's in the argument 1. So these two things are kind of similar, although they do output different things. So we mentioned like syntactic structure, right, when you're talking about the different levels of linguistic hierarchy. So, all right, James ate some cheese whilst thinking about the play. Is that proper usage of whilst? Does anyone know? I feel like it should be while, right? All right, no one knows. Okay. Maybe the YouTube people know. Okay, so here, like, we're going to form a tree structure where one of the verbs in this, one of the words in the sentence is going to be the root of the sentence. It's often the verb. So like ate here, right? And then there are going to be relations to different words in the sentence that start at ate. So ate is related to James because James is a noun subject. And so we have these other things. I'm not going to click on whilst because I'm suspicious of it. Let's go to thinking. So here, like, thinking is related to about the play because about is the preposition modifying this, and the object of the preposition is the play. So you can kind of like click and see the hierarchical structure of this. Constituency parsing does something similar, except you don't get these relations between words. Instead, I guess I can just show you. You get these constituent types. So here, went to the corner shop to buy some eggs, milk, and bread for breakfast. This is called a verb phrase. To the corner shop, this whole span is labeled as a prepositional phrase. The corner shop, and so on. So another interesting task, which is kind of related to named entity recognition, but goes a step further, is coreference resolution. So here, let's see, I'll select one of these things. So I have this document. We are looking for a region of central Italy bordering the Adriatic Sea, blah, blah, blah. So let's just look at the outputs. What this is going to do is find all of the spans of text that are referring to the same entity or same thing. So here, a region of central Italy bordering the Adriatic Sea is coreferent. It refers to the area, right? The area and this phrase are referring to the same thing. And it, this pronoun, is also referring to the same thing, right? So a coreference resolver is going to say that all of these spans are about entity 0. Similarly, many sheep and them are, apparently I didn't read this far, are referring to the same thing, so they're associated with entity 1. So why might this task be useful practically? Yeah, so imagine like I'm having a conversation with you, right? And I say, you know, this class is great, Mohit's a really good lecturer. And you might say, yeah, Mohit's a great lecturer. But at some point, we're not going to start using my name like over and over again. You might say, yeah, he's really great, right? And then he, who is that he referring to, right? Is it you? Is it me? It's important when you're trying to understand the conversation to be able to resolve the pronouns and these other, you know, like the area, this kind of noun phrase, what exactly is the area, maybe it was described previously, and, you know, it kind of combines with all these other tasks, right? So if the area is being modified in a way here, so it's, we're explaining that it's mountainous, right, over here, then I might want to know that this overall entity that's being described is mountainous. So if I'm kind of coming up with some representation of the area, I would want to update it every time the area is referred to with some new information. Right? So this task is useful. It's also very difficult. All right, so we'll talk about language modeling in a bit. There's also, so reading comprehension used to be a very popular task. You'll see it's like not a very natural task, and so people are focusing now on more realistic question answering settings, but here is a passage from the, I guess, Wikipedia article probably about the matrix. So we have all of these sentences, and then the task is, given this passage, I can ask a question about the passage. The caveat here is that the answer should be somewhere in the passage. So this is not a very natural task, right? Because the person asking the question should know already what is in the knowledge document here. But that aside, I can ask this model who stars in the matrix, and this question gets sent to the model along with this passage, and we run this, and it says Keanu Reeves. So it worked pretty well on this simple question. We could also ask it another question. Anyone have any ideas? Maybe to stump the model? I guess we all have to read this to come up with a question, which is annoying. Oh, what is that even in the, but it's not really clear that this is Keanu, right? So. What? Okay, but this one is pretty easy, but we'll try it. I would be very disappointed if it doesn't get this. Also, there's only 1 year in this whole document, so like, it doesn't even need, I bet if you just said which year, Wow, it's so smart.
How about where is the matrix?
Okay, where is the matrix? Oops. What is there a span of text answering that here?
I guess
Oh, the simulated reality. Okay. It tried. All right, so you can see some of the limitations of these models already here. Okay, so normally I would stop here, but over the past year, there's been another kind of advance in NLP technologies, and that is mainly driven by OpenAI's GPT-3 model. So I wanted to show you some examples of this, and this is just a language model. So unlike all of these models, oh, sorry, let me, the YouTube has a lot of questions. Machine translation tasks. It's not a, how do we get a hierarchical output like this? Is it using a graph NN? Don't know what this is referring to. This is a good coreference problem, so I will just ignore this. Resolving ambiguities in, oh, these are answers to the questions I was saying. Okay, I got to figure out a better way of monitoring this. Sorry to all of you YouTube viewers. All 16 of you. Okay, so back to this. Right, like I was saying, these are all models that have been developed, and they only solve this particular task, right? So this Elmo-based named entity recognition model can only do named entity recognition. It can't do any other task. Similarly, this coreference model, all it can do is find these spans that refer to each other. This question answering model, right? It can like barely even do the task that it's meant for, let alone like any other task. So like I was saying, in language modeling, you just have this one task of given some input, you predict the next word. So let's take a look at how probably the best, at least semi-publicly available language model does on this task. So someone give me just like some prompt of text. Actually, this is a little dangerous because who knows what this thing will spit out. But yeah, anyone want to give me like some sort of, yes?
UMass student is trying very hard to find this.
Okay, a UMass student is trying very hard to find, oh, can you see this? To find the classroom for her NLP class. All right, let's have it produce like, I don't know, 183 words in response to this. Oh my god, so bad. Sometimes it's actually good. I was hoping it would be good, but it's actually like, the goal of this project is to, okay. All right, let's, okay, this is actually a good teaching experience. So when we are generating from these models, there's an element of randomness associated with it. So these parameters here control how diverse the outputs are. And if those values are set to like optimize for diversity, the text that's generated becomes kind of irrelevant. Let's try again. Oh. My God, why did you pick this like the worst prompt? All right, so okay, so actually this is good because this is a common failure case of these language models, is that they tend to repeat what they've already seen. Although, like, it literally saw one sentence. All right, let's give it another sentence. Maybe that'll make it better. Yes. So the weather is very unpredictable? Oh, okay. Well, I want to add it to this sentence. Is that what you're saying? She eventually found the class, but okay. I mean, what is she going to do next?
But the dragon was guarding the door.
Okay, there we go. I like that. All right. See what you do with that. Oh, all right. So, okay. So she tried to open the door, but the dragon turned on her. She ran away from the dragon. The dragon chased her down a hallway. Oh my god, this is quite dark. I think we'll finish with this. I mean, this is pretty interesting too. It seems to have completed the story and then started analyzing this story. But you got to admit, like, this is pretty impressive, right? It actually generated some sort of coherent story, given your second sentence was much better than your first one. Okay, so this is the task of language modeling, right? It's predicting one word at a time, so you can see that if I click this, you'll see one word follow the next incrementally, right? It's actually kind of going left to right, predicting a word at a time. We can solve a number of NLP tasks in this way by just telling this language model what the task is. So this is called a prompt. So let's say I wanted to solve sentiment analysis. Okay, so I can go here. I'll just copy all of these like sentences here. So I want to solve the task of sentiment analysis. Maybe I will say, sentence and sentiment. And so here's my sentence, and this one seems to be positive. Let's go back. So I'm only going to give it 4 examples of the task. I'm going to give it all 4 of these examples from this model. So unremittingly awful. Okay, so this is negative. I don't know if it actually needs 4. I actually don't know what's going to happen at all. Clearly, that should be obvious. Okay, so this one has, actually maybe I'll do like a colon or something. So this is an interesting thing, is like when you're doing this kind of prompt-based learning, you need to be careful how you, oh, whoops. What is this? Negative? And finally, these are so long. Okay, this is clearly positive. Okay, so I put 4 training examples. They're not actually training examples because the model is fixed, right? It's this black box thing from OpenAI that I'm obviously not training. I can't even load this into the memory of any of the machines in our big GPU cluster. So the model is fixed. It's just a language model. How about someone give me a sentence that you want the model to figure out the sentiment of? Not you, someone else. Anyone else? All right.
OpenAI story really sucks.
Nice, nice. Okay. I don't think anything else is really needed, right? All right, let's see what it does. Maybe I'll set the response length to like something small. Okay, so like it did actually predict that this was negative. It also generated more sentences along with their. I should have told it to just produce one word. But you can see that it learned the pattern that it didn't learn it actually because it's not being trained, but it was able to pick up the pattern in the input itself and then apply that pattern to some new text. And this is all generated in this left to right way, right? So one thing that's now happening in the NLP community is like a model like this one is just trained to do sentiment analysis. It doesn't have much utility apart from this task. And if we can get a model like this, which can do all sorts of things as we've seen, I mean, it's not great at everything, but it at least is capable of solving a wide variety of tasks. If we can make its sentiment capability good enough that it's competitive with this model, it's just a lot better, right? Because this one can do so many other things as well. So through this semester, we'll build our way up till this point of understanding how this model works and what its limitations are, how we can proceed to make better versions of this, and so on. Another cool thing about this, which is kind of showing how NLP algorithms, the particular language modeling, have changed other fields, is another OpenAI model called the Codex. So some of you might have heard of this. It's basically a language model that's trained on like GitHub. So GitHub has a lot of code, but it also has a lot of comments, right? Comments are usually in some form of natural language, depending on how good of a coder you are, or how committed you are to making your code readable and so on. And so they have, I think this is really cool because I don't like coding personally. So we can see, I mean, obviously it's flawed, but we're just going to go to some of their examples. So, okay, like if we're coding in Python, let's say, we can just put a comment in, like ask the user for their name and say hello. And hopefully this thing will produce the code for this. Okay, so it did that, right? So this is very simple. You might say, okay, well maybe so many people had this in GitHub that it's just copying that. So let's see, there's some more like complicated thing. All right, and then we can get to creating our own scenario and see how it does. So here, I have to create 2 lists and then combine them into a list of 100 full names. So let's see how this does. I wonder where it got those names from. Oh, I should have. Did this work? Is that actually correct? Yeah, it's pretty good. So it made both of these lists, and then it did this loop, and then it's randomly choosing a first name and a last name, and then, like, I could probably run this and it would work. All right, does someone want to come up with a more complicated task for this model to do? What's that? Okay, but it could just like print all of them out, right? All right. What exactly is the wording that you want? To print out the first 10 Fibonacci numbers? Okay, I'm curious what happens. But I feel like it's just copying something, right? Like give me something that is, like you don't think anyone else on GitHub would have ever written before. This is maybe hard to think of. Yes? Okay, let's make it in Python though. I'm not sure if it can do other. Oh, it could. Okay, this is a little too far. Okay, well maybe some of these other examples will. I will say I was trying this out for producing the course schedule. Like I gave it the first 2 weeks and then I asked it to produce the remaining. And what it did was like, so, okay, maybe I'll go to the course schedule. This is like kind of irrelevant now, but hang on. So the schedule is like a bunch of these lists. So I gave it these 2 weeks and then I asked it to generate the next 2 weeks. And it actually produced topics that were relevant, like week 3, word embeddings, week 4, or recurrent neural networks and stuff. But then it got caught in one of the loops like we saw before. It was like YouTube link from 2020 here, YouTube link from 2019 here, YouTube link from, so it kind of worked, but it kind of didn't work. Okay, so anyway, like this is the exact same model architecture from both the text generation stuff we saw and this code generation stuff, right? it's a model that is trained on GitHub to predict the next word. When I say word, there's some like complexity there, which we'll talk about when we actually get more into detail on these models. But the same exact principle applies to code. It applies to natural language. People are even using these models for images and videos now. So like the transformer model started out in NLP and is now kind of taken over many applied machine learning fields, is what I wanted to get out of this. So unfortunately, you guys cannot access this for your projects. Actually, if some of you have access, you should feel free to use it, although you may have to pay, so keep that in mind. All right, so I don't have anything else for today. I will see you all on Wednesday. Sorry, yeah, next Wednesday.